Okay, so let's have a look at the Leaving Certificate Maths Higher Level Paper 1 for 2018, and let's have a look at question 5. So here we have what they call a sieve of Sundaram, and it's an infinite table of arithmetic sequences. So the terms in the first 4 rows and the first 4 columns of the table are shown. So if we look at these, we've got 4, 7, 10, 13. So it's arithmetic, we're told it's arithmetic, so it's going up by 3 each time. If we look at the second row here, it's going up by 5 each time. And if we look at the third row, they're going up by 7 each time. And the fourth row going up by 9 each time. So if you think about it, really, even the differences here are going up in arithmetic sequences. So here we have differences. So I could write D's here if you like. So we have 3, 5, 7, 9. These are our D's, our differences. And it's the same with the rows as well. I mean, we have 4, 7, 10, 13, 7, 12, 7, 17, 22, and so on. So the rows and the columns are the same numbers, or the same sequences. Now let's have a look at the questions then. So the first one just says, find the difference between the sums of the first 45 terms in the first 2 rows. So we've got to look at the first 2 rows. So this one here and this one here. And we've got to find the difference between the sums of the first 45 terms. So let's look at row 1 first of all. So row 1 is 4, 7, 10, 13, and so on. And we see the difference there. We see, we see A here is 4, and our common difference is 3. It's going up in 3s. So we can work out we have to work out the sum of the first 45 terms of this row. So we know from our tables anyway that the sum of the first n terms in an arithmetic sequence is n over 2 times 2a plus n minus 1 times d. So all we've got to do really is just substitute these a's and d's and n's into this formula to work out the sum of the first 45 rows. So we're looking for S45. So n is 45. So we want 45 over 2. We want twice the first term, which is 4, plus n, which is 45 minus 1, times our common difference, which is 3. So when you work this out, anyway, you get 45 over 2, 2 4s 8, plus we have 45 minus 1, which is 44. 44 times 3 is 132. 44 times 3, 2 4 is 12, 1, 2 4 is 12, 13, yes. So 132 here, okay. So let's just work this out. When you work that out, then you get 140 divided by 2 multiplied by 45. That gives you 3150. Okay, so we have the sum of the first 45 terms in the first row, in row 1. So now all we got to do is do exactly the same for row 2. And then subtract them. This is row 2. So row 2 then, what numbers are they? Let's have a look. We have 7, 12, 17, and 22. 7, 12, 17, and 22. So here we have A is equal to 7, and we have our common difference is 7, 8, 9, 10, 11, 12, which is 5. Have I got that right? Yep, 5. Okay, so again, we do exactly the same thing again. So we want S45. So that's going to be 45 over 2 times twice the first term, which is 7, plus n, which is 45, minus 1 times d, this time, which is 5. Now, when you work that out, you get 5265. Just do exactly the same thing again. The question actually says here, find the difference between the sums of the first 45 terms. The difference between the sums. Well, we have, so a difference here. difference is just equal to 5265 minus 3150. And that gives us 2115. So that's the difference between the sums of the first 45 terms of the first two rows. So this is our answer here. Okay, so let's look at the next question then. Find a number which is in the 60th row and the 70th column. So the 60th row and the 70th column. So if we just look at the rows here, what I'm going to do is find A for the 60th row. I'm just going to look at the 60th row. So I'm going to look at the 60th row. Now I know I'm going to work out A for the 60th row, the first term in the 60th row, and I'm going to work out D for the 60th row. So how am I going to work out A for the 60th row? Well, if we look at our table here again, these are our rows across here, and I'm looking for the 60th number. Really, I'm looking for the 60th number in this column here, if you like. So I know that A is 4 and D is 3. So really I'm looking for T60. I'm looking for T60 in this particular column here. So T60. So let's look for that first of all. So I'm looking for a Tn first of all, which is A plus n minus 1 times D. I'm looking for T60. Term number 60 in that column will give me the first term in the 60th row, if you can follow that. So T60 is going to be A, which is 4, plus 60 minus 1 times, we know the difference in the first column is 3. So you work this out, you get 4 plus 59 times 3, and when you do that you get 181. So I now know that A in the 60th row is 181. The first number in the 60th row is 181. Now how am I going to work out D for that particular row? Well, again, if we go back to where I started, we had a look at these differences. The difference in the first row is 3. The difference in the second row is 5. The difference in the third row is 7. The difference in the fourth row is 9. The differences themselves form an arithmetic sequence. The differences themselves form an arithmetic sequence. 3, 5, 7, 9, where A is 3 and D is 2. The difference of the differences, if you like, is 2. So I can work out the difference in the 60th row as well, what D would be in the 60th row. So if I come down along here, this is row 1, row 2, row 3, row 4. Row 60 will have a difference out here somewhere. I can work that out by using this particular sequence of numbers here. So 3, 5, 7, 9. So if we go back here, our differences are 3, 5, 7, 9, and so on. So this is in row number 1, row number 2, row number 3, row number 4. But if I want to work out the difference, what would my difference be in the 60th row? So if I take a look at this, I'll call this A1, if you like, just to give it a different A from these A's over here, is 3. And my difference, I'll call it D1 here, is 2. So this would be the difference, the common difference in my D's, if you like. So what would T60 be then? What would be the difference in my 60th row then? Well, that would be just, again, it's going to be A plus n minus 1 times D. So my A here is 3, my n is 60, subtracting 1, and my D is 2 here. When you work that out, you get 121. So in other words, the difference in the 60th row is 121. This is the difference in the first, the second, the third, the fourth row, the difference in the 60th row is 121. So I now know the difference in the 60th row. I have my first term and the common difference for the 60th row. What's the question then? The question asks, find the number which is in the 60th row and the 70th column. In other words, the 60th row starts with 181, but I've got to go out 70 places. So in other words, I've got to find T70. I've got to find T70 for the 60th row using this A and this D here. So let's do that. I want T70. I know that A is 181 plus n minus 1, which is 70 minus 1, times a D of 121. When you work that out, you get 8,530. 8,530. So this is it's in the 60th row and it's in the 70th column. Okay, so that's that question done. Okay, so let's move down then to part B here. Okay, so part B then just says the first two terms of a sequence are 4 and 2. So we have 4 and 2. The general term is defined, and by the way, this is A1. We can put it here, A1, and this is A2. We'll have an A3, an A4, an A5, A6. I'll do a few of them. A7, A8, and so on. Now we have the first two. We're given the first two as 4 and 2. The general term is defined by an is equal to an minus 1 minus an minus 2, where n is greater than or equal to 3. So what does this mean? This means that any particular term n is equal to the previous term, that's the an minus 1, minus the previous term, which is an minus 2. So write out the next 6 terms. So what they're saying here then is that if I want to work out A3, I take A2 and subtract A1. So an is equal to an minus 1, the previous term, minus the previous term, an minus 2. So let's start then. We want A3. So what they're saying here is A3 is equal to, that's an minus 1 would be A2 minus an minus 2, so that would be A1. So we want A2, which is 2. We want to subtract A1, which is 4. So we get minus 2. So A3 here is just going to be minus 2. Let's have a look at A4. Is going to be equal to A3 minus A2. So A3 is minus 2. We want to subtract A2, which is 2. So we get minus 4. Okay, so that is minus 4 is A4. Let's have a look at A5. A5 is A4 minus A3. So A4 is minus 4. We want to subtract minus 2. So A4, that's minus 4 plus 2, which is minus 2. So this A5 here is minus 2. Let's keep going. Let's do A6. We got to do the first 6. So A6 is A5 minus A4. So A5 is minus 2. A4 is minus 4. So it's minus 4 here. So that'll give me minus 2 plus 4, which is 2. So A6 is 2. Okay, so we were only asked for the first 6, so write out the next 6 terms of the sequence and hence find the value of A2019. Okay, so looking at this sequence of numbers here, I can see immediately that it's not arithmetic. We're not adding a particular number to each term to find the next term. And I also know it's not quadratic either. I've done that. You can do it yourselves, but you can do the second difference and you'll find it's not quadratic. So it must be some kind of, it's also not exponential, by the way. We're not multiplying by anything to get the next term. So what I'm thinking here is that maybe it's some kind of repeating pattern. So let's do the next two just to see. So let's take A7. So A7 is equal to A6 minus A5. Well, A6 is 2, and we want to subtract A5, which is minus 2. So that's 2 plus 2, which is 4. Okay, so it looks like we have a 4 here, and we have a 4 here. It looks like it may be repeating. So let's just have a look at the next one. The next one will confirm it. A8 is equal to A7 minus A6. So A7 is 4, and we want to subtract A6, which is 2. So 4 minus 2 is 2. We get 2 here, so it is repeating. We can see here that we have 6 terms here, and then we're starting here again with 4 and 2. So 4 and 2. Once we have the first 2 here, we're going to get all of these. So we have 4 and 2 again, so again we're going to get these again. So it will keep repeating. So it is a repeating pattern. It's a repeating pattern of 6 terms. So in other words, A9, you will find then that that's this term here, which is minus 2, and so on and so on. So it's a repeating term of 6 patterns. So how is that going to help us? Well, we want a 2019, I should say, a 2019. So let's have a look at that. We want a 2019. So we want the 2019th term. Well, if we take 2019, we know the pattern is repeating every six terms. So if we divide by 6, we get 336.5. So we know that it goes in 336 times with something left over. Now, if we take 336 and multiply it by 6, let me just do that quickly. Grab my calculator. 336 multiplied by 6 will give us 2016. So that means really what we've got here, it goes in 216 times, and we're going to end up with a remainder of 3. A remainder of 3. So what does that actually mean? Well, if we take 2019 and we divide by 6, it goes in 336 times exactly. So 336 times will bring us up to this 2 here, but there's a remainder of 3. So this is remainder 1, this will be remainder 2, this will be remainder 3. So remainder 3 will bring us up to minus 2. So the 2019th term is minus 2. So A2019 is minus 2. This is our answer here. Okay, and that's it for this particular question.